Okay, we're going to look at exponential functions. And the first thing we're going to do is convert the following expressions from expanded form into combined form. So if I have a plus a, I can write that as 2 times a. That's condensed. And then plus b times b times, b plus b plus b plus b. How many times am I adding b? 1, 2, 3, 4, 5. So it's going to be 5 times b. That's condensed form. So when we have repeated addition, adding the same thing over and over, it turns into multiplication. Repeated addition can be turned into multiplication for a shortcut. Let's look at this thing, b times b times b. So that's going to be b to the power of 3. We use an exponent and then times x. There's only one x. So now the b times the b times the b 3 times, that turns into b cubed. So repeated multiplication turns into an exponent. All right. Down here, we've got some repeated multiplication, b times b, so that'll be b squared, the exponent of 2. Then we've got x times x times x, so it's times x to the third because it's multiplied by itself 3 times. Then we have plus a plus a plus a. That's repeated addition, so 3 times repeated addition turns into multiplication. So this would be b squared x cubed plus 3a. All right, this guy here is repeated multiplication, so 3 to the power of 2, or we could just call that 9 if we want, times more repeated multiplication, so x times x times x is x to the third, plus repeated addition, k plus k. So repeated addition becomes multiplication, and then plus p. So it's we'll do 3 squared is 9, x cubed plus 2k plus p. All right, that's going to help us understand exponential functions. Exponential functions are functions made of exponential expressions where the base, we really shouldn't use the term in the definition. Where the base is a constant, the exponent is a variable. So the variable is the exponent. That's kind of the key here. All right, so where's the x located? The variable. Remember, f of x is just kind of like a y. Right? And then the x is located in the exponent. That means like an example could be like these would be numbers, like 3 times 2 to the x. That's an exponential because x is in the exponent. So that's where it gets the name exponential from. X is in the exponent. Now, that exponent means repeated multiplication. So I think it's best to think of this as a, and it's got an exponent of 1. So it's just 1a and then times, because a times b, there's multiplication right there. Then b to the x. It means b times b times b. It's repeated multiplication of b. And we don't want to specify how many times. We're just going to say x times. So we can change the x. So sometimes if x is 2, it means b times b twice. If x is 5, then it would mean b times b times b 5 times. All right, so we're just going to say it's repeated multiplication of this b x times. I'm trying to squeeze that in there. All right, so where a is the initial value, and that can't be equal to 0, and then x is any real number, so just that would be the number of times that you're multiplying, and b is the base, which is a positive constant not equal to 1. All right, so circle which ones are exponential functions. Well, this one, the x is the base, and the number 2 is the exponent. So that is not exponential. Here, the number 2 is the base, and the variable x is the exponent. That is exponential. When the variable is in the exponent, that's an exponential. So this one, no, because the variable x is the base. So that's not exponential. Here, the variable x is in the exponent of 7, or is the exponent of 7. So that one's exponential. All right. Now we're going to say, let's do some examples here. So let f of x equal 3 to the x, g of x equal 1/4 to the x, and h of x to equal 10 to the x minus 2. So notice these are all exponentials because the x is in the exponent. In this exponent, we even have more stuff. Not just x, but we have x minus 2 as our entire exponent. But still, x is in there. So find the following values, f of 2. So f of 2 means I'm using the function, f of x, which is equal to 3 to the power of x. And that means if we're doing f of 2, we're going to replace x with 2. So then 3 squared is 9. If we're doing this on the calculator, right, we do 3 to the exponent of 2, we get 9. Right here, they're going f of 1. So f of x, again, is 3 to the x. I'm just rewriting that here. Then now I want to plug in -1 for x. So I get 3 to the -1. I'm not sure what that equals. Let's look over here. 3 to the -1 equals 1/3. Okay, that's how negative exponents work. If you learned rules of exponents in Algebra 1, I'm not going to rehash them in this video because the video will be too long. If you don't know why that works, we'll talk about it in class. Okay, I'll be happy to help you with your exponent rules, or maybe we'll talk about it anyway as a class real quick. All right, g of -3. Well, now we're working with g of x. So g of x is the fraction 1/4 to the power of x. So then g of -3 means we're plugging in -3 for x. Again, I'm not sure what that means, so I'm just going to go ahead and use my calculator. We've got 1/4, and then, I want to do that. And then to the power of -3. And that equals 64. Again, we can talk about this in class if you don't remember how exponents and negative exponents especially work. H of 2.3. So now we're on to the function h. H of x equals 10 to the exponent x minus 2. So then h of 2.3 equals 10 to the 2.3 minus 2. So I know that that simplifies to 10 to the 0.3 because 2.3 minus 2 is just 0.3. So let's do 10 to the exponent. If I'm using Desmos and I have to put multiple things in the exponent, I need parentheses. 2.3 minus 2. I'm just going to write the whole original thing out. And that gives me about 1.995. We'll just call it that. We'll end the decimal there. This shows you that, yeah, exponents can also be decimals, and that has a little bit, that's a weird meaning. Like, I know when the exponent is a whole number like 2, I know that means 3 times 3 twice. But what does it mean if, like, the exponent is a decimal? It's like 10 times itself, 0.3 times. That's very weird. So at that point, yeah, we definitely are going to need a calculator for that, okay? F of 0, so f of x is 3 to the x. F of 0 is going to be 3 to the 0, and that's going to just be 1. We could come back here to confirm, but I know that one to be 1 because I remember my exponent rule, anything to the 0 power is 1. All right, and then so g to the 0, we're using g of x now. G of x equals 1/4 to the power of x. So g of 0 equals 1/4 to the power of 0, which I know is equal to 1 because anything to the 0 power equals 1. All right, so now we're going to look at linear functions versus exponential functions. Actually, we're going to stop this video here, and I'm going to make a separate video for linear versus exponential. This was just your intro to exponential functions.